questions that you're having are just pattern type questions, figuring out how to get from one number to the next. And sometimes it just takes a little while. It just takes a little bit of time to figure out what the pattern is, because you got a lot of choices. It could be add, subtract, multiply, divide. It could be a combination of a few of them. So it's just something that if you have something where you're trying to find some kind of a pattern, sometimes you just have to be patient and look at the numbers and see what you can figure out. For this particular pattern here, from 480 to 492 is plus 12. From 492 down to 486 is minus 6. This again, from this number to this number, is plus 12, and this is minus 6. So we're starting to figure out the pattern is plus 12 minus 6, plus 12 minus 6. So if the pattern continues, this should be plus 12, and it is, because 2 plus 2 would be 4, and then we'd have 10 more. So that would be plus 12. So our final part of this pattern should be a minus 6. And if I do 504, take away 6, we're going to have 498. Some patterns or sets of numbers can have a couple of different patterns that it goes by here. If I look at this one is kind of tricky, I think anyway, because it is a combination of a few. But sometimes you just have to locate some patterns. So, maybe I'll start with how much bigger each one is as we go, and we can locate a pattern from there. 3 to 7 is 4. From 7 to 15 is 8. From 15 to 31 is 16. There we have 32. So it looks like, just from looking at this pattern here, we keep doubling the amount that we're going up each time. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So if we follow that pattern, 32 times 2 is 64. So that means that our next number is going to go up 64 spots. And 64 plus 63, 60 plus 60, 6 plus 6 is 12, so that'd be 120 plus 7. So our answer is going to be 127. Now that's not the only way to do this pattern. If I look at this, and this one takes a little bit more work to figure out, but if you're pretty good with numbers, I think that this is something that's possible. 3 to get to 7. I believe 3 to get to 7, we could do this too. If I have 3 and I need to get to 7, I could do times 2 and then plus 1. 3 times 2 is 6, plus 1 is 7. I could follow that pattern. I could go times 2 plus 1, 14, 15. I could go times 2 plus 1. 15 times 2 is 30, plus 1, 31. Times 2 plus 1. 31 times 2 would be 62, plus 1 would be 63, which is what we have here. So if we follow that pattern again, we would think that if we times 2 and plus 1, we're going to get 127. So plus 1, so that would be 63. So if I times 2 to this, 63 times 2 is going to be 126, plus 1, it is going to be 127. So another acceptable pattern here is times 2 plus 1. The next three kind of go together, so I guess I'll just put those on there at the same time. All we're doing in the first two, we've got to figure out what does x equal to make this number sentence true. And the first one is 4 times x. Remember, number right beside the variable or the letter is multiplication. 4 times blank is 20. You just need to figure out what that blank would be. Now, I can look at this and just tell you that 4 times 5 is 20 because I know my basic facts. You can just do it that way. If you need to use an inverse operation, you can just do the opposite. If this says times 4 here, just divide by 4 on the other side. I could just do divide by 4, and that's also going to get you 5. So that's just another way that you could make that happen. For this one, we've got x divide 3 equals 9. Okay, so we need to find something that we can divide by 3 to get 9. Now, again, knowing my basic facts, I know that 9 times 3, which is basically just like using inverse operations, If this says divide by 3, I can times by 3. 9 times 3 I know is 27. And I also know that if I put this in for x, 27 divided by 3 does equal 9. So that would make 27 a correct answer here. The bottom one is a little bit different. They give you a number and they want to know if it works. Okay? So right here we've basically got 2 plus 3 times x, and I'm going to put parentheses around this because one common mistake, and we're going to talk about order of operations this year, but a common mistake is people will want to add this 2 plus 3 right here. And you can't do that. You've got to do any multiplication and division first. So we'd have to do 3 times whatever x is first. Let's see if it works. So I'm going to put 2 in for where x is. I'll just take x out. I'll even use the little dot here. I'll do 3 times 2. Will it equal 17? So I know that 3 times 2 is going to be 6. So now I have 2 plus 6 equals 17. Is that sentence true? Well, of course it's not, because 2 plus 6 is 8, not 17. So we know that our attempt to try 2 did not work. So we know that 2 is not the solution to this problem. Now we could figure out what the actual solution to this problem is, just basically with a little thinking about it anyway. If we did inverse operations, I could subtract this 2 over here and get 15, and then I know that 3 times 5 is 15. So I know that x equals 5. I could also probably just look at it and see, well, what could I use? If I used 2 and it came out to be 8. If I use 3, that'd be 9, 10, 11. Nope. If I use 4, that'd be 12, 13, 14. Nope. I need 3 more, which means I need an extra 3. So if I do 5 times 3, that's 15, plus 2 more. That gets you 17. So x equals 5 is the actual answer here. All right, last one. We just have to write this out in an expression form here. X decreased by 7. So all we have to do is we know we're using the variable x somewhere in here. We know we're using 7, and our keyword is decrease, which means subtract. So we want x, whatever x is, to get decreased by 7. So that's just going to simply be x minus 7. Okay. There's a lot of ways we could write this and switch this up. This is the answer to this one, but just think about other keywords we have here. If we say a number decreased by 7 is 4, we can write that too. A number, we could use any number. So I could use y decrease, still subtract by 7 is, remember, means equals 4. Okay, so if I switch it up, it's going to look like that. One of the most common things with subtraction is which order to put them in. This one's easy because it's a number decreased by 7. Sometimes if it says like x less than 7, you just have to know which order to put them in. So really be careful with subtraction on that case. But this was your answer to the actual problem.